Hello.
I am preparing a tool for the repair of this milling machine. First, I will do a couple of linear movements. I tested this machine to prepare for its repair. I found out how much the X, Y, Z axes deviated from their ideal position. This is the deviation of the y-axis relative to the axis of rotation of the spindle. This is the deviation of the x-axis. Now I have enough information to remove metal. But I need to make this special spotting tool or template with a cutout in the middle. Without it, it will be difficult for me to make the exact plane on a dovetail slide. Showing how I made this surface plate with high precision. A special spotting tool of the required size was assembled by electric welding. To relieve stress from electric welding, I annealed the workpiece in an oven. I check whether the stress of the welds have been relieved. In places where the seams are located, bulges appeared. So, we see that annealing relieved stress in the metal. Bulges did not appear in all seams, as it depends on the welding sequence. The first welds push outward, later welds pull inward. And I am preparing it for further processing. I am preparing a workpiece for processing on a surface grinder. This is the machine the spotting tool was ground on. Primary processing is done. Now I am starting to create an accurate plane. After grinding, I prefer to smooth the surface with abrasive paper on a flat plate to remove microscopic sharp protrusions. Now the sharp edges are smoothed out. I cover with marker ink. Now I need my very flat surface plate. I leveled it myself, and there is a video about it. I use kerosene. Where the spotting tool touches the surface plate, the ink will rub off. The surface touches only two places. I remove metal from these places. At this stage, I use fine sandpaper. I ink again. I am removing ink again. The contact area has increased slightly. I continue to work. Fourteen cycles have already been passed here. The contact area has significantly increased. It is constantly necessary to thoroughly clean everything from the abrasive. Another layer of ink. I do not show everything, it will be very long. Most of it is similar, and it is scabbed. The same operation is repeated many times. I wanted to take a break from the monotonous work. I wondered if it was possible to draw like that. Self-portrait impromptu. places of contact. I will lap the spotting tool next. Fairly fine abrasive and oil. Flat slab for lapping from structural steel. Lapping for a long time and slowly, in order to produce less heat. I attached the lapping plate to the table. It's more convenient. I put a weight on the spotting tool. Surface wear must be uniform. If the workpiece is moved evenly, covering all places, the workpiece becomes flatter. Also, the lap will become flatter the more it is used if moved evenly and randomly. Stuck, not going to fall. Final lapping on a plate with chromium oxide. At the same time, chromium oxide is evenly distributed. Last lapping with chromium oxide. More and more starts to stack. I reduce the layer of kerosene with chromium oxide. The layer of kerosene becomes thinner. The planes begin to stack together. Surfaces are getting more and more sticky. Lower surface plate 35 kilograms. But the surface becomes more and more dry, and adhesion decreases. Enough. Now the surface is almost perfectly flat. You are probably wondering what we will see through an optical flat glass. a monochromatic light with a wavelength of 589 nanometers from a low-pressure sodium lamp. The interference lines are almost parallel. The surface is quite flat. Anyone interested in glass optical flares or monochromatic light sources at a reasonable price, contact me by email. My homemade special spotting tool for repairing the Y feed in my milling machines is ready. Now I can start repairing, scraping, dovetail slides. Thank you for your attention. Thank you for your support on Patreon. Goodbye.